Isn't it though? I mean, and I was
Yeah.
surprised that MRO is so sensitive, or I mean, has such good optics or sensing equipment that it can pick up such a small. I mean, the Phoenix Lander is only. I mean, in this image, we're looking at something that's maybe what 10 feet across, something like that, or a couple meters
Yeah,
across.
I think it's about 15 or so across.
Oh,
Yeah.
when the it's 15 feet.
15 meters.
Oh, 15 meters across. Oh, okay, that's a little bigger than I thought. Those solar panels must fold out quite a bit then.
Yeah,
Uh,
they do.
oh,
And the bluish objects on the outside, of course, are the solar panels, and
yeah.
they show up blue in our image. These are all false color images. We don't take natural color images of
Oh,
Mars.
okay.
The reason being Mars is red, of course, and everything would look red. So we choose some different colors to kind of pull out the differences.
Ah,
And in this false color image, solar panels show up very well in the blue, blue-green,
yeah.
and
Okay.
they reflect a lot of blue light. They don't show up in our red or near infrared very well. They just showed up as black amorphous blobs. But you put all three filters together, and we got this nice and pretty well registered image.
Right. Yeah, and for anyone who's looking at the image who aren't familiar with the Phoenix Lander, the center part that's kind of the body of the lander, and the two kind of side parts there, the wings, those are the solar panels that folded out upon landing. Yeah, very interesting. Now back to exploration of the rest of the solar system. Um, first maybe, however, I should ask if you have a. Someone did ask another question about specific how to triangulate the signal correctly. Did you see that
Yeah,
question in the chat?
I don't really have all the math
Oh,
in my head to do this just very
sure.
well. I don't think I can do it justice. But and actually, this is a lot of what the engineers and Phoenix themselves are working on.
Oh,
But the little bit that I know is that Phoenix Lander doesn't communicate directly with the Earth. It relays its information through two spacecrafts, Mars Odyssey and our spacecraft,
okay.
Mars Reconnaissance Orbiter. And there's two UHF radios on both of these spacecraft.
Okay.
And so they use that signal to triangulate where it is on the surface of Mars. And we get that signal from slightly different angles on different orbits, and so
Sure.
they're able to use all of that data. Um,
I see.
and I'm sure there's a other host of things that they do that I don't even know about. So
Yeah, I understand that. Yeah. Uh, Now back to the I was going to say about exploring the rest of the solar system. Are you afraid that there's going to be a lot of focus away from Mars? I think that's a little unfortunate for two reasons. Is that Mars is easy to get there. It's faster to get to.
mhm,
Like Phoenix only took 6 months, right? Something
that's
like that.
correct.
And I mean, we're sending a probe right now. Horizons, New Horizons, is it? That's going
Yeah,
out.
all the
It's
way to Pluto.
to Pluto and Kuiper Belt objects. You're going to try
Mhm.
and find a couple different Kuiper Belt objects to observe. And that's not until that's still 3 years or something, isn't it? 4 years before it's going to arrive.
Right, 2014, I think it
Oh
is.
yeah, I mean, I suppose that's a trade-off with space exploration is the vast distances, but it sure would be nice to continue at least some projects on Mars because I would think that would help us refine our automated software in the robotic missions so that
Hmm.
in future missions farther out, when say you build a probe in the year 2008 and it's not going to arrive at this destination until 2016, I mean, you definitely want to make sure that's working properly because I mean, by 2016 we'll have much better technology. So I think in the interim we could be sending probes yet to Mars or to closer planets or the moon to continue refining our capabilities and then periodically sending more missions to the outer solar system. That's kind of my view on it. But I suppose it's a small pie to divvy up between all the different missions.
It is, and I think in some ways this change in fortunes was unanticipated. No one really expected so much excitement in the outer solar
Oh,
system.
okay.
So now you're seeing a bunch of very excited outer solar system specialists saying, how come we're spending all of this money on Mars when we just discovered things that could rival Mars in,
Sure.
in excitement, including astrobiological potential. So that's just beginning, and you'll see that settled. I hope it would be settled with funding for Mars doesn't go away, and we get a whole lot more funding for the outer solar system as well.
Oh,
But
yeah,
we'll
that's
see how that goes.
yeah, that'd be the ideal thing. I mean, there is a lot of science that can be focused on around the world, with public and private money. And it seems, in general, space exploration has been a little bit, I don't know, declining in the last couple of decades as far as enthusiasm and money. I'm unsure if that's what you see from your end, Richard.
I have perceived that until now,
Oh.
and I think what has drastically changed is the resolution of our images, and suddenly we're seeing pictures that not only excite geologists and excite planetary science experts, but immediately a person in the public can see these things and get excited about it. They know what they're looking at. It's that high of resolution now.
Yeah, I was excited to see when Japan sent their Kaguya probe to the moon. I can't say it.
Selene, I think they
Celine,
renamed it.
yeah,
Selene.
that's not. I mean, it goes by a couple of different names, but yeah, Celine. They had a high resolution, high def camera on there, high
Yes.
definition camera, and some of the images coming back from the moon were absolutely spectacular.
Yeah,
and
exactly. They're able to. So a lot of the astronauts who have gone to the moon, they always felt let down by their pictures because they could never explain just